Never mind, I just used a black one. Okay. So the area, so this will be about the information about the force. So in this way, this is our x1 plane. In this x1 plane, we have the force. How many? So that is the corresponding stress element multiplied with corresponding area, right? So that will be equal to tau 11, tau 11, L1. Let me put the L1 here. L, tau 11, L1, tau 11. 3 components, and L2, tau 1, L1. And L1, tau 1, 3. Yes.
Okay, so then you apply that to everything else.
Yeah, so the same thing here on the x2 plane. We have the force, and that is L2, tau 21, L2, tau 22, L2, tau 23. And in the x3, we have force component is L3, tau 31, L3, tau 32, L3, tau 33. So far so good, except the projection of the area here. I need you to get things to think through, okay? Or otherwise, who can contribute a cake, the square cake? I will show you next time.
Wait, you're gonna apply this to cake? Are you gonna bring cake in?
No, I'm waiting for someone to donate a cake for me.
Why don't you just make a cake?
I don't know how to make a cake.
There are recipes online.
Yeah, it's easy to say.
Yeah, sorry. The recipe online too.
Yeah, but he probably has more of the ingredients than we.
So if you have a cake, you can show me. I can bring a knife. I can cut into the corner to show the presence. And I need a volunteer, and then I will.
How about you get your daughter to bake a cake?
Yeah,
That's your
okay.
experience.
Okay.
But it has to taste good.
But I need
So
a
that we can
volunteer,
eat it.
then stand in front of me in the x1 direction. I will project that cake onto your face.
We all volunteer, Sarah.
The area will be exactly like this one. Okay, if everything.
Oh yeah. How about we do this the week for like the weekend of like Springfest? Like, not like that Wednesday before Springfest because we can't have class Friday anyways.
That's why I'll probably be in Android.
So what? We get cake, right?
Or you do only like make cake.
Okay, so we're back to here. And now we've done this one, and we have this kind of similar figure like this one. So next step, we want to get equilibrium equations. Okay, but to do the equilibrium equations in 3-dimensional, and that will take a little bit challenging things, but here we can try. The first step to achieve the equilibrium equation is to formulate what we call the Cauchy formula. Cauchy formula is nothing but like this. You see right now on the 3 planes behind the inclined plane, on the 3 triangle planes, we have the force components. Those force components in total, how many? This is a force component in 1 direction, in 2 directions, in 3 directions. This is a force component in 1, 2, 3 directions. Similar way in 1, 2, 3 directions. So 9 force components, they must be in equilibrium with the reaction force on this inclined plane. Because we are given is stressed, the deformable object. Once we cut into the free body diagram, right away we know that on any inclined plane there should exist any reaction forces, right? And the reaction forces, the role of the reaction forces is to be in equilibrium with the given one, right? Okay, so now how to represent the reaction force on the cut plane? We do this one. So let me say, again, here is a representation skills. let me represent the reaction force on the inclined plane by this. This is the force in 3 directions. This is a reaction force in 1 direction. This is a reaction force in 2 directions. The 3 are the reaction force components. The 3 must be in balance with all the 9. Are we good? Again, here I show the green one is the simply reaction force. And that is a similar way is here we have this is a stress multiplied with area, so this is a reaction force here, just like we're showing here in 2D. Are we good? Okay, and because here the content is not in any fundamental textbook, so I wish you can comprehend at this moment, and then can hopefully today you can complete the homework questions. So far so good? Any questions before I proceed? Don't think about the cake. I won't make it. Okay, good? Okay. And the notations for the reaction forces, which is a reaction internal, is this. We're using T. T for the N representing is the
tangential. So
yeah, the T just the symbol for reaction force. Okay, and N representing is this is reaction force in an inclined plane that has a normal vector N, and this is in 2 directions. So this is the 3 direction. So this is in 1 direction. Okay, are we okay? Okay, so now we formulate the equilibrium equations. So Tn1, this is a force in x1 direction must be in balance with all the forces from among the 9 they are in 1 direction. So here we look at for among the 9 components which are in pointing to 1 direction. This one in 1 direction, right? And this one in 1 direction. This one in 1 direction. So this one must be in balance with that one. So that is L1 tau 1 1 plus L2 tau 2 1 plus L3 tau 3 1. Are we good? And in a similar way, tau N2, this one must be in balance by all the forces in 2 directions. So that is highlighted by 2 underlines here. Okay, so that is L1 tau 1 2, L2 2 2, L3 3 2, N3, and again by this L1 tau 3 1 plus L2 tau 3 2 plus L3 tau 3 3. Sorry, made a mistake. Tau 1 3. Okay.
I'm still a little confused about like the area part.
Okay, so this is piece of cake, and we can solve for that one later. We just need a cake, so that will become piece of cake. Okay. So before that you formulate your questions, this one are called the Cauchy's formula. Okay, in your homework assignment, I'm asking you to calculate what is the Tn1, 2, 3 in certain problem in terms of numbers. You simply plug in this formula and to calculate per these equations. And in that homework, I give you the n. For example, say I just make one. Okay, so for example, 2 1 2. This is not the unit vectors. In this formula, L1 2 3 must be the unit vector component. So that one you have to translate into the unit vectors. That is how much? 1, 3, 2,
2, 3, 1, 2.
and yes. Okay, because 2 squared plus 1 squared plus 2 squared equal to 3. So you have to convert it into unit vector, and this is your L1, this is the L2, this is L3. This is the only point you need to pay attention before you apply the Cauchy's formula. If you are using non-unit vectors, then everything will be scaled up. It's not correct. Okay? Good enough?